All right, so here is a video for your notes for lesson 1-5. So if you will make sure anything that I write down that you also write down on your paper, so your notes should look just like mine. Here we go. So we are looking at equations that have a proportional relationship. Again, it's lesson 1-5, and this is just part 1, so it's the first part of the lesson. Make sure you've written your name on your paper. Your class period, it is math, but you can write what period you have math on there. Today's date is the 13th, so 9/13/21. And again, we are going to look at how can we write equations to represent a proportional relationship and identify the constant of proportionality in the equation representing a proportional relationship. So all of those include some vocabulary words that we may not know yet. So let's go down and let's first look at our vocabulary. So if you will fill in the blank with me. Two quantities are proportional. Two quantities are proportional if the ratios comparing them are equivalent. 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 And equivalent means equal. So two quantities are proportional if the ratios, and remember a ratio is a fraction. Okay, we'll talk about that here in a second. If the ratios comparing them are equivalent or are equal, the ratio is called the constant of proportionality. Okay, the ratio is called the constant of proportionality. Proportional relationships can be represented by an equation in the form y is equal to kx, where k is the constant of proportionality. Okay, so we're going to have two things that have a relationship, and so the most important thing for you to realize here is the relationship is going to be proportional. That is something that you guys have been talking about. And where do you find the constant of proportionality? It is k, which is always in front of the x. Okay, so always in front of the x. Okay, I'm going to make a little star over here. It's always in front of x. Okay, and you can draw a little arrow over there to your k. That's going to be your constant of proportionality. So if we want to, you've looked at graphs of proportional relationships, you realize that they are straight lines that have to go through the origin. So how can we represent that as an equation? So how can the constant of proportionality be represented? So we represent it using, you'll kind of notice that this line down here is a straight line. It does go through the origin. We're going to represent it as a linear relationship. A linear relationship is proportional. A linear relationship is proportional. And so every linear relationship that you're going to look at is going to have that equation y is equal to kx. And we'll come back and we can fill in with our notes a couple of other things. But again, the main thing for you to remember is k is the constant of proportionality. Okay. And it's given us an example right here. So an example is y is equal to 3x. So this is my equation. Y is equal to 3x. If I was to graph that, this is what the graph would look like. A couple things to notice. The graph is proportional. It does go through the origin of 0, 0. And then, so the main question for you to ask yourself is, what is the constant of proportionality? How is the x variable, how is the x coordinate, what's its relationship to the y coordinate? And so you will see the constant of proportionality is 3. Okay. So what does that mean? Let me just give you a quick example before we go into our examples down here. If 3 is the constant of proportionality, notice it's beside the x. And anytime you see things that are side by side, remember they are being multiplied. So 3 times x will give me the y coordinate on the graph. So let me say that again. 3 times the x coordinate on the graph will give me the y coordinate. So let's look at my graph here for just a second, just to give you an example. If I look at this point on the graph right here, that point on the graph is 1 is the x coordinate, and then it goes up 1, 2, 3. So 3 is the y coordinate. Okay. So their relationship is proportional, and it does follow this 3 times x. Well, 3 times 1 is 3. And so 3 is my y coordinate. So that's how they got that point on that graph. All right, but we'll break that down as we go through. So again, the first thing that you need to be able to do is identifying that constant of proportionality, which if you have the equation, we know how to do that because we know that it's going to be in front of the x. So let's look at our problem here. It says Olivia bought 6 containers of yogurt for $7.68. The equation, big hint there if I'm trying to find the constant of proportionality, is y is equal to 1.28x, can be used to represent the situation, where y represents the total cost of the yogurt and x represents the number of containers bought. All right, you're going to have to flip your paper over. Y is equal to kx, where k is the constant of proportionality. So again, we've said that over and over. So here was the equation from the other side of the paper. X represented the number of containers of yogurt she bought. Y represented the total cost. So in the equation for the cost of the yogurt, the constant of proportionality is, well, guess what? What's the only number that we have in that equation? The number that's in front of the x. 1.28. So what does that mean? So that's the other piece that we've got to know. The constant of proportionality is the same as a unit rate. So the constant of proportionality means that the cost of each means 1, okay? 1 container of yogurt is $1.28. So the constant of proportionality is 1.28, and the unit rate is $1.28 per container. Okay. So again, something to remember again about that constant of proportionality. It is all about 1. Okay, 1 container of yogurt. So here's a check problem. Take a minute, pause the video, read the check problem, and see if you can answer this. After you have answered it yourself, okay, come back and I will go over it. So again, pause the video, go read the check and answer it before you listen to my explanation. All right. So you should have already answered this, and here's the explanation. So it said an airplane traveled 780 miles in 4 hours. The equation y is equal to 195x models this situation. Part A says, what is the constant of proportionality? You should have, remember, constant also means it's a number. Okay, so you should have written a number for part A. So if we look at our equation, again, the only number that we have in the equation, the number in front of the x is 195. So 195 is our constant of proportionality. Part B then said, what does the constant of proportionality represent in the context of the problem? All right. Well, first of all, let's just kind of look at our answer choices. Our constant of proportionality is 195. There is only one answer choice that has 195, but let's just make sure that the other ones do not make sense. So we will look, and it's 780 miles in 4 hours. So 390 miles per hour. Does that even make sense? Well, if I take in my calculator, let me grab mine. And if I found the unit rate, if I did 780 divided by 4, well, that's 195. That's our constant of proportionality. They're not going 390 miles per hour. So it is not A. An airplane travels 1 mile per 4 hours. Well, look back in the problem. That's not true. It said it went 780 miles in 4 hours. It's not B. An airplane travels 1 mile per 585 hours. Well, does that make sense? If it can go 780 miles in 4 hours, then why does it take 585 hours to go 1 mile? Doesn't make sense. So again, D is the only one that has 195. The airplane travels 195 miles per hour. So D. Faster than any car that I have seen. All right, one more, just to kind of apply what we have been using and going over. Jack is in charge of the 120,000 gallon community swimming pool. Each spring, he drains the pool in order to clean it. When finished, he refills the pool with fresh water. Jack can fill the pool with 500 gallons of water in 5 minutes. Write an equation that represents the relationship between the total number of gallons Y and the number of minutes spent filling up the pool X. Part B says, how long will it take it to become completely filled? Okay, here we go. So we're applying what we have just talked about. And let's look at it. So we know for part A that if it says write an equation, we know that our equation has to say y is equal to kx. So let's see if we can go back in the problem and figure out the only thing that I need to fill in, which is k. So a couple of things again that we need to remember about k. So k was our constant of proportionality. But it also, if we go back up here, it says it's our unit rate. Well, we have a rate in this problem. It says up here at the top that Jack can fill the pool with 500 gallons of water in 5 minutes. That's a rate. But it's not a unit rate. A unit rate would be how much he could fill the pool in 1 minute. But we can figure that out. If I take 500 gallons and divide it by 5 minutes, okay, then I will have what it takes for it to, how many gallons it does per minute. So in my calculator, if I need to, 500 divided by 5 is 100. Okay, so that means that Jack fills the pool 100 gallons per minute. Okay, I'm actually going to write this over here, 100 gallons per minute. Pretty fast. All right, so then let's fill that in. Where should our 100 go? That is our unit rate, our constant of proportionality that goes in for K. Y is equal to 100 K. And that's it. That is our equation. Once you have filled in K, you've got the equation. So how can we figure out how long will it take to become completely filled? Well, what is full? if we go back to the problem, it says Jack is in charge of the 120,000 gallon community swimming pool. So it's full when it has 120,000 gallons in it. Well, if I think about my equation, I'm trying to think about the easiest way for you to do this. What do we know about the equation? Write an equation that represents the relationship between the total number of gallons, Y, and the number of minutes, X. So let's go back to the equation. Y is equal to 100X. And let's look at this. So what are we trying to find? We're trying to find how long, which would be the minutes. Well, that's X. That's what we're going to try to find. So then that means I need to fill in Y so that I can solve for X. Well, Y represents how big is my pool? Well, we just underlined in our problem 120,000 gallons is equal to 100X. And now we can solve that. To get X by itself, this is 100 times X, so we need to undo multiplication so we can divide by 100. And 120,000 divided by 100 is 1,200 minutes. Now, what if the equation confuses you? Okay, let me give you another way for you to be able to think about this. How long will it take for it to be completely filled? All right, if it's going 100 gallons per minute, if you take the number of gallons in the pool, 120,000, yes, and divide it by how many can go in per minute, 100. Again, you could put that in your calculator, divided by 100, and you will still get 1,200 minutes. So 1,200 minutes. All right, there you go.